The purpose of this worksheet is to go through how you would apply stoichiometry calculations to a lab. All right, this is about the preparation of salicylic acid in a reaction. The reaction equation is given here. Remember that we always need a balanced chemical equation in order to be able to do stoichiometry, and in fact that equation is balanced. You can add up the number of atoms of each element to try to figure that out, but you can also trust me. So it's balanced. All right, you'll notice that our goal is to find out which student got the better grade and why from the student data up here. So a few things to point out about the data. There's the mass of the empty container, the flask. Then there's the mass of the flask and the starting material, which we know from the reaction is going to be acetic anhydride. All right. I'm sorry, is salicylic acid. So salicylic acid is C7H6O3, and that's the flask plus salicylic acid. Well, what you'll notice is that in order to be able to figure out the mass of just the C7H6O3, you've got to subtract these two numbers. All right, that's the volume of acetic anhydride, mass of the watch glass, and watch glass plus the final product. To get the final product, you also have to subtract, because you'll notice this is just the watch glass and this is the watch glass in the product. All right, the calculations are similar for student 2 here. All right, when we do stoichiometry and we're using masses, we're always going to need molar masses. So this lab asks us to calculate out the molar masses of each of these at the beginning. So acetic anhydride C4H6O3. So I'm going to do on my calculator, I'm going to do 12 times 4 plus 6 times 1 plus 16 times 3. And when I do that, I'm going to get 102 grams. Salicylic acid is 12 times 7 plus 6 times 1 plus 16 times 3. All those numbers are from the periodic table, 138 grams. And aspirin, 12 times 9 plus, and you get the idea. All right, we're going to move to the back now. Oh, I don't have a back. Let's go to the next page. All right, so the question asks, how many moles of salicylic acid were added to the reaction mixture? We're only going to be doing student 1. Student 1, how many moles were added? And I'm going to do this on a separate sheet of paper because there's not a lot of space on the original sheet. So salicylic acid was the original mass here. So the goal is that we're going to subtract these two numbers, then we're going to convert to moles. We have the salicylic acid molar mass here. So I need to do 39.961 grams minus 37.820 grams, and that's going to get us our answer, which is 37.961. Alright, I just did some of my math here while I paused the video. So I found out that this number is 2.141 grams. That's of the salicylic acid, C7H8O4. Again, I talked about that on the front of the sheet where you just subtract the two numbers from the lab. Alright, so that's going to be my answer to number 2. So 2.141 grams. Alright, the next question asks us to use the density to find the number of moles. Oh, wait, I'm sorry, I didn't even answer the first question. That's about moles. So I'm in grams. How do you turn grams to moles? Divide by molar mass. All right, so I'm going to do 138 grams. That's the molar mass from the front of the paper. And I get 0.0155 moles. And again, that's the salicylic acid. All right, that's number 2. And so I actually didn't do that correctly. I need to do 0.0155 moles. All right, next up, number 3. We need to do the same thing for the acetic anhydride. That was given in milliliters. And so if I know the milliliters, it's 5.0 milliliters. And I know the density, it's 1.05 grams per milliliter. I can find the mass, because mass over volume is density. All right, so I'm going to plug those in, and when I get that the mass is equal to 4.76 grams. I need to do the same thing. I need to turn that to moles. 6 grams over 1 times. This time the molar mass is 102 grams, is 1 mole. And I get that 0.0466 moles. So right here, 0.0466 moles. All right, so what I did in number 2 and 3 is I found the moles of salicylic acid, one of the reactants, and I found the moles of acetic anhydride, the other reactant. Number 4, they ask us to find what's the limiting reactant. Reagent's just a synonym for reactant. So what we're going to do is, we're already in moles. That was step 1. If in doubt, mole it out. Now we're just going to divide by the coefficient. Luckily, the coefficients of each of these is 1. So when we divide these numbers by 1, it's going to be the same number. And we found out that 0.0155 moles is the smaller number. So salicylic acid is limiting. All right, now step 5. Now that when I know that's limiting, this is the only number that matters. This number, ignore it. This is the excess reactant. All right, so I'm going to need to find the theoretical yield in grams of aspirin made. So I'm going to take this number and I'm going to use dimensional analysis to find out the mass of aspirin. All right, so I didn't do these calculations yet, so I'm going to just pause the video for a second so I can do them. Okay, so to find the theoretical yield in grams, I'm starting with the starting amount and I'm calculating out grams of aspirin. All right, so that's a dimensional analysis problem. So if I go to number 4 and I go to dimensional analysis, I know I'm going from moles to grams. And again, I'm starting with that 0.0155 moles of the salicylic acid, and I'm going to grams of aspirin. If you look at the equation on the front, this one is salicylic acid and this one is aspirin. All right, they are 1-to-1 mole ratio. I need to know the mole ratio in order to be able to do the equation. All right, so 0.0155 moles of the salicylic acid. I need to use the mole ratio to get from salicylic acid, that's 1 mole of C7H8O4. Again, the 1 comes from the balanced equation, that's the coefficient, is 1 mole of the aspirin, C9H8O4. Again, the 1 comes from the balanced equation. Finally, I need to use the molar mass to get back to grams. And remember, when you use a molar mass is always equal to 1 mole. So that's going to get us our mass, which is 2.79 grams of the aspirin. So that's how much should be made based on the reaction. How much actually was made? Well, you take your two numbers from the table, number 5, and you subtract them. So subtract these two numbers. And when I subtract these two numbers, I'm running out of time here, so I'm just going to finish this up. So the actual yield was 1.745. Again, I subtracted those two numbers. And finally, percent yield. You guys know that the percent yield is actual over theoretical. Well, we have the actual, it's 1.745 grams. We have the theoretical, it's 2.79 grams. Multiplied by 100 just to make it into a percentage, and that's 62.5. All right, you need to do the rest of the calculations yourself to be able to say which student got a better grade and why. It has to do with who got the better percent yield.